Students, today we have a practical of the Decentric classification. While discussing the theory and numerical portion, as I told you what is meant by the Decentric. So Decentric is supported by the CART method or approach or technique we can say, and CART stands for the classification and regression technique. So Decentric is the one and only we can say the important method which support the both approaches. So because the Decentric support the both kind of the nature of the data we can say. So by this naturing of the data or supporting by the different kind of the flavor of the data, Decentric can be used by the two way. So we have the Decentric classification and we have the Decentric regression. So today we will see the Decentric classification with help of the simple example. So you can say what is the problem we have. So our problem we have the to classify the data based on the label. So what is the labels we have? So we have the different labels by which you can see. And I'm just opening the one more important point. So Decentric classifier, this is the example I would like to share. Decentric classification, I have that many examples, but I would like to discuss this example. That is the simple example by which you can easily understand. So I'm just in front of you. I'm just restarting the kernel of this Jupyter notebook, and I'm clearing all the output in front of you to justify the answer what we are getting step by step. So you can see I have just flushed out all the my data over here, and from this point I just need to explain the thing properly. So what is our problem? From the our problem is saying to us we are trying to implement the Decentric using the classification. So first we have the very steps very simple. So now this program is a filtered program because this is explained by the other start. So I will write the some amendment of code over here whenever it is required, or some special statement or comments whenever it is required. So I'm going to click on the first point, that is the implementation of the Decentric using the classification. So cell by cell or step by step I will execute in front of you. Whenever you feel any problem, so you can ask me, and whenever you are not able to understand any single command or some points, then you can ask me. So implementation of the Decentric using the classification we have. So let us start. Now I'm clicking on the run. So what is the first step? First step is saying to us we need to import the necessary libraries. So what are those necessary library I'm importing over here? I'm importing the NumPy library and I'm making its object, that is NP or PD for the partner library for using the data frame preparation. And numerical operation performing, we have to use the NumPy library. So I'm using, we need to plot the our graph. So I'm using the C1 library. So in this case, you can easily check. There are many things you are able to see over here. So what you are saying, we are using the C1 library. C1 is our library, and I'm making its object, that is SN. So you can change your name. You can write your name as well over here. This is only the object name over here. So while using the this library, what we have to do, we can plot the different kind of the graph, because in this world we are not having the single kind of the graph, we are having the many kind of the graph by which we can interpret our information. And Metronome Library, as you know, this is your favorite library while plotting the graph inside the our Jupyter notebook, or the ID we can use. So we have to plot the graph, so we have to use. Now, %matplotlib inline is saying to us, you can represent your graph or data, whatever you want to represent by the graphical way, inside the notebook only. So that is the point. So in front of you, I'm executing. So it will take some time to import all the libraries into the our this program or this code over here. So now you can easily check, easily see the something over here. In between, let us discuss some other points what we have to expect. Our expect to, after importing the different libraries, so what is our objective on which we can perform the task, or we can perform the practical part. So here we have a data set. I'm giving its data name as over here the balance hyperscale dot data. This data set I'm using from the internet, so I'm just downloading the database into my laptop, and that after I'm trying to interpret your information easily over here. So reading the data set or create the data frame. So how we can do? We can create this data set is a simple way. So df is the data frame is the name of the variable. You can put your name. You can take the different name. So in front of you, I'm just able to see the it's different thing. I'm just putting the my df. My df means my data frame. I'm just changing different name. So after reading this point, my df will contain all the data which is stored into the balance dash scale dot data. So with the help of the read CSV method, I'm reading this data set over here, and with the help of the this point, I'm able to print all the things. So I'm just writing only this single statement, what it will display. The above line, the below line, the df. So now print the data set via data frame value. So in front of I'm writing over here, so you can easily see. So after executing this code, you will able to see what is the information we are containing by this point. So let me change its name. Previously it was a df. Now I'm changing its my df. Now let me execute this code. So you can easily see, is it visible to all the data set information D1, 1.1, 1.2, 1.3, is it visible to all? Now we have a 624 rows and 5 columns. Is it visible to all?
Yes, sir.
So what is contained? A database or data set which contain the entire information form of our data set. So we have this data, we are using this data only. Now, after this point, what we have to step, we have to understand. You can easily say we are using the 1.1, 1.2, 1.3, and so on, so over here. But that is not a meaningful information. So if we need to transform, we need to rename all these columns names we can do. So what is the syntax? For learning the Python programming, it is necessary to learn some basic syntax over here. So in my course, while discussing the practical part, I'm pretty sure you will able to understand some more syntax about the Python. So your Python programming will also improve. So how we can update, how we can change the column name. So we can also change the column name by using the simple syntaxes. So we can also represent the user defined column names, columns name we can write column names rather than actual column names. So actual column names was 1.1, 1.2 something. But I want to represent these information in according to us. So definitely we can do. So we will override the previous values of the data frame variables. That's why we have the my variable. So I'm just changing here what I changed. My previous variable was a my df. Okay. So prepare the data set as per the user defined column name. So I'm remembering my machine learning process. Gather data. After gathering data, you are trying to prepare some data set, data frame according to the user's requirement. Now, why? Because it was simple, my dear student. We can prepare the data as according to the our need. It is also simple concept. So that is my point over here. So we can easily do all the things. So preparing the data set is a necessary step. But if column names are not justifying the proper information, so we can also modify, we can alter our column name from our data frame. But after changing the column name over here, it will not reflect to the actual data frame. That is the point you have to understand. It will not reflect to the actual data set. In the actual data set, the information will be in the form of the 1.2, 1.3, and so on. But here we have storing all the data into our my df data frame variable. So it will reflect to only the my df data variables only, data frame variable. That is the part you have to understand. So what I'm doing right now, I'm just giving the column names what I can have. First column name, that is we have the 1. Second column name, we have the first column name, we have the b. Second column name, we have the 1. Second column name, we have the 1.2, and third 1.2 and 4, we have the 1.3. The total we have the 5 columns. So here I am giving the first column name as a class name rather than the b. I am giving the column name that is left weight. Next I am giving the left distance. Next I am giving the right weight, and next I am giving the right distance. So you can see the 1 is replaced by the class name, 1.2 replaced by the left weight, okay, and 1.1 is replaced by the left distance, 1.2 is replaced by the right weight, and 1.3 is replaced by the right distance. So you can see, observe over here. So this is not a replacement point over here. This is just I'm defining the variable name, that is a column name, that is the array type of the variable which contain the 5 different type of the information. So while defining the data frame, just as my data frame, so I'm what it will do, fill up the from the read CSV method, I'm calling the same file, that is a balance hyphen scale data file, and I'm giving the column names by passing the parameter name, that is names, and I'm passing its value. So what is the its value? I need to pass column name. It's previously defined by the few minutes ago. So I'm just changing in front of you, just like column. Okay, I change the column. So here I have to pass the parameter column. And I can separate all the information by the comma, so I can do so. It's optional, but if you want to write, then you can write. You can put the you can insert the, or you can put the space, or you can put the different symbol. So comma is very common symbol I can use for differentiate the data, so I can do. So I am just passing this information. So this variable that was my df variable will be replaced by, now it is will be replaced. Okay, it will be replaced, and from this my df it will display the updated data frame which contain the column name rather than the its simple name. So let me execute this code in front of you. So my justification will be properly. So let me show. So now it is visible to all right now. So previously it was what it was. Previously what it was, B 1.1.1, 1.2, 1.3. It is visible to all right now. And now it is changed into the class name, weight, left distance, right weight, and right distance. Yes, tell me right now.
Yes, I'm visible.
So what we have actually, what is that? I'm writing over here. In the actual data set, there were no column names are defined. So by using the above code, we have replaced the first column. We have not replaced, we have added column names to the our data frame variable. That is a point. Variable. Variable. And what is the name of the my data frame variable? My df. So you can see I'm adding the column name. So after adding my column name, the class name, left weight, left distance. So it is added over here. So previously there was a B. So B was the class name, but as a first we have not added the column name. So it treated as it will be the column name. So in the actual data frame. So that's why we got the 6 to 4 rows. But after this point, after adding the column name, this is the first column that contains the 1, 1.1, 1.2, and 1.3. It is replaced by form of the as a row. It counted as a first row. So I can write over here for avoiding a confusion. So first row in the actual data set was treated as a column, as a sequence of a column. But after applying the adding of the columns, we got one more row. So now you can easily check. I'm just executing this code in front of you once again. So now you can say now we got the 6 to 5 rows rather than the 6 to 4, because the first rows that is treated as a sequence of the columns. Now it is considered as a one more row. So now we got the 6 to 5, and sequence we have the 0 to 6 to 4. So this is the step which defines the how you are preparing the data set. You can remove the unnecessary rows which contain the null values. So that is a step which is considered into the data preparation. So now after data preparation, is it clear to all right now?
Yes, sir.
Sir,
Yes.
what is SCP the syntax?
What is the syntax?
What is SCP?
As it is separator, you can separate your data column names by the comma. So it's an option, but if you want to write, then you can write. It's optional actually.
Sir, we can increase the separation.
Yes, sir. You can separate your data columns by putting the space symbol like dollar. You can put the comma. You can put the spaces only. So it's all optional. It's your choice. Whatever you want to write. So for standard purpose, most of the people love to use the comma. That is a meaningful information. That is the only the way we can say. But it is an optional. But if you are not putting, so it will consider as a space comma. By default, it contains the space only.
Okay, sir.
Okay, clear?
Sir, here.
Okay. So now the student asked me, sir, how we can see the entire data. So by the syntax, we will able to see now we have the total 624 rows, 625 rows. Now I need to display only the top 5 elements. So it's a very simple syntax. df on df now it changed into the my df. So I'm just updating my variable name. So just see. With about this syntax, I'm able to see the very limited amount of data. That is the top five rows I'm able to see. Top five, not elements. It's I can write top rows. Okay, top 5 rows. So you can easily see all these codes. So I'm executing this code in front of you once again over here. Now you can see. Now there is an important syntax while learning the many things you can easily check. So info is our method which is a part of the Untitled library which describe that how many rows and how many columns we have and really we have any null values or not. So maybe any column name, any column. Suppose any column which may contain the null value, so how we can check. So there are many commands by which you can do, there are many syntax you can do. There is a simple method by which we can easily detect how many null values or how many is our column contain null values or not. That is the point. So by using the info method of the data frame, we can see the details of the entire data set with proper information. So I'm executing this code in front of you. What is my data frame variable name? My df. So I'm executing this code in front of you and let us run this code. Now, you can easily see the some information. So rows index are 0 to 624 and total are the entries we have the 625. Is it true? Yes, of course, it is true. And data columns, how many columns we have total? We have the 5 columns. Now it is coming. And what are the column names? Row, we have the 0 to 4, 6 column index we have. And what is the name of the columns we have given? Class name, left weight, left distance, right weight, right distance. And total number we have the entries non-null. We have the 625, 625, 625 non-null values. It means we suppose we are getting the any column which contains the 623. It means there are two null values we have. So we have to remove or we have to identify those rows and those columns part we have to remove. So that is a part of the preparing the data set. So definitely we have this statement. And what is the total memory which is consumed by our data frame? 24.5 plus something like this case. Now it is clear to all right now. This is the beauty of the info method. Is it clear to all right now?
Yes, sir.
So while learning the so after understanding this point, now it's time to explore the data analysis step, or we can say the ED steps. So if you remember the machine learning process, first step was collecting the data set or collecting the database information. After collecting the data, what we are doing, we are preparing the data. After preparing data, now we have to analyze our data, how many information we have. So analyzing the data is basically we can say it's the optional part, but if you're applying for see some information, then you can see. So first, we are displaying the graph based on the features. Features means class name. So how many features we have, how many columns we have. So based on the different features, based different columns names, we can easily see our graph. So I'm using the counter plot graph which just display the how many number of the particular class we can contain. That is a important point. So you can note it down the few seconds ago, few minutes ago, you have noted down. Class name will contain the some values B, R, and so and so, and L also we have. So B, R, L, and so and so information. So with the help of this counter plot graph, which described that how many number of the R we have, how many number of the L and we have in our class name. So with the help of this code, we can easily see. So what I'm doing, I'm just using the object of the my C1 plot library. So SNS dot counter plot, I'm using the counter plot graph, and in which I'm passing the data frame variable along with the its only the first part, that is the class name. So class name I'm passing. So let us use to display the some graph based on the features I'm doing. With this graph, we will see the total number of the R, L, and B, that is the right, left, and balanced values. So let me execute this code in front of you, then you can easily see. Now, this graph is visible to all. Is it visible to all?
Yes, sir.
So with the help of the graph, we can say the B is our value, which is smaller than the R and L. So with this graph, we can easily say, and with the help of the other method, we can use the count. So with the help of the count method, you can apply and the total number of the thing we can say. So there are many things, there are many commands by which we can say. So this graph is describe nothing, just describe that B is smaller than the R and L. So B is contain the minimum value. Now it is true. Is it clear to all right now?
Yes, sir.
Okay, I hope previously while learning the Python programming, you have just seen this kind of the graph, but you have not seen. So no problem. With the help of the machine learning, you can also able to understand something properly. Now, we are just following the one features. Can we apply the multiple features on which we can easily evaluate it? Of course, it is also possible. So in the next command, we have this syntax. Now, we are trying to see the result of the total number of the B, R, and L. So we have seen in the previously, now we are also trying to do so. So with respect to left weight value. So our first column, that is the left weight. Next column, first column was the class name. Next column we have the left weight. Next left distance. Next right weight and right distance. So we have the 5 columns. So with respectively left weight, we have to identify how many class which is falling by the left weight and which is falling by the right weight and which is falling by the left. So definitely we have this point. So with respectively, we need to identify total number of the features, that's class name, with respectively towards the, or with respectively we can say the left weight. So here what I have to do, I have to use this command. So this describes the how many times R BL is total number with respect to left weight. So in the total left weight we have the values 1, 2, 3, 4, 5. In the left we have the many values 1, 2, 3, 4, 5. You can see once again. See in the left weight we have the many values 1, 1, 1 and 5, 5 at the last we have. So there are many values which contain the ranges from the 1 to 5. So same thing I am applying over here, and this describe, I can write over here properly for betterment. This describe how many times RBL features, that is the class name, will come with respectively to the left weight. So what I have to pass? I have to pass the main column name, that is the left weight. So I am passing over here, and U is just basically that define the third parameter, second parameter you are taking to use as a second parameter. So that is the class name, you can easily say. So total weight will be the main component, or we can say the main part, and with the help of the using the u parameter. So what is the u parameter? U parameter describe that by having seen the total left weight, you are trying to count the, you are trying to use the class name. So I'm passing here the class name, and I have to use the myDF because I have changed my parameter df to myDF. I'm executing this code so the output will be more clear in front of you. Having seen the output, the concept will be clear to all. Now, this diagram is clear to all. So this diagram is telling you right now, when we have the left weight, value 1, then class name B is lesser than the L and R. And you can see that when we have the left weight value 1, then right is our features which is higher. But in the case of the class left with 5, when we have the value left with 5, at that moment, at the time, B is the class feature which is also lesser than the R and L. But here the L is L is maximum value. So here when we have the left weight value 5, then RL is the more containable part, we can say. That is the point. So this is the diagram which describes the combination of the two features that have the bar graph. You can easily see. When we have this value, then how many times it is coming. So this is our simple graph. Is it visible to right now, and it is clear to all right now?
Yes, sir.
And same thing you can go for the right weight. So I'm not changing anything over here. I'm just changing the df to the my df, and just you can also see this result. So when we have the right weight value 1, 2, 3, 4, 5, so which describe that when we have the right weight value 1, so at a time the L, that is a feature name, we can say our class name, which is the higher than the others. Definitely we have this one. So this is the just idea which describe and which is known as the exploiting data analysis. Exploiting data analysis is not an easy thing. We have to follow the many things, many syntaxes. So the people, those who will think about the data analysis is a big activity. Of course, it is a big activity. To analyze the data, it means you are performing the many operation on the data to identify the data nature and data type, and we can say the what is the percentage of data we are having to understand all the things. And definitely all these are having by the this kind of the thing. So here I'm just showing the small amount of the exploratory data analysis by which you can easily understand, yes, is it possible. So but it was optional, you want to use, then you can use, else you can remove. But for you showing the my proof here, of course it is also possible, so I'm giving this information over here. Okay, right now any doubt, or is it clear to right now?
Yes, sir, it's clear.
Okay, so after this point, a student asked me, sir, when we have to build the model? Yes, of course, we have to build the model. So before building the model, what we will do? You will use the many things. So before building the model, you have to understand what is the data set or data frame you have. So you have to choose the appropriate X value, that is independent variable value, and you have to choose the appropriate dependent values on which you have decide what would be your independent variable or what would be your dependent variable. So definitely we have. So after exploring the data analysis by the seeing our two previous graph, what you have been observed? We have been observed that is the class names are independent or dependent. You have to understand. So finally you are been observed the class names are dependent on the our left weight, right weight parameters or other parameter as well. So X means left weight, right distance, left distance could be the independent variable, while class name will be the dependent variable, because we are finding the class name based on the our left weight or right weight or other parameter as well. Is it true or not? Just tell me right now. Is it true? Class name will be the our class name will be the our independent variable, dependent variable. That would be dependent because that is depend on the other parameter. Is it true?
Yes, sir.
So before building the model, just split the data into the two parts, one is training data and testing data. So we have to do this thing. So here what we are doing. First, we are copying the all the information into the X except the one. So you can use the drop method. So from the data frame, my data frame I have taken. From the my data frame, we have the 5 columns except to the one column. So which column I'm accepting? Class name. So except to the my class name, all the column will be copied, all the data will be copied into the my data frame. And axis one define the, that is the axis one define the column. This axis one will be when you are putting the axis equal to 1, it means we are talking about the our first column. So definitely the class name which is presenting the column 1. Okay, so we are not accepting this column. It defines that except to the one column that is the class name, all data columns will be considered over here. So X will be contained by the X. What will contain X? I'm writing here. X will keep columns are columns that is, I can write over here, left weight, right, left distance, left distance, right, right weight, and right distance. I can say, of course, these are the other thing will come over here. And we have discarded our one part. So from this syntax, what we can say, we can write the whole thing. Or it is better idea, you can write the all the columns directly, except to the one you can write directly, or you can use this syntax by the drop method we can do. So there are many ways why which we can do. And Y column, that is a target variable, or we can say it is also known as the dependent variable. So class name are depend on the other features or other parameters, or we can say this is also known as a dependent variable. Dependent variable. So I can write over here dependent variable. So here what we have been observed many here having seen, we have a three different classes R, B, and N. Okay. So let us print the what will contain the X and what will contain the YY, and in the next step, what we have to do, we have to apply this method to splitting. So before building the model, we have to split our data two parts. So I have divided two parts into training data and testing data. But before that, what we have done, we have just separated the data respectively what we have done. So let me execute this code in front of you. Now you can see. So X will contain the left weight, left distance, right weight, and right distance, and the total we have the 4 columns, and Y will contain the class name. So it is also containing the class name 1. Now it is clear to all right now. Tell me right now. Is it clear?
Yes, sir.
Okay, good. So now it's time to train the model. So before training the model, you have to divide the data into two parts: training, testing data, and training data. So just like the linear regression or various tables of linear regression we have seen, we have to use the following syntax to use this data. So in front of you, I will update some code, and now what we have to use. So here previously I have taken the 40% of the data as a testing data, but if you want to some amendment, then we can do. So total we have the 625 data or rows. Out of these data, how many percentage you want to take as a testing data? So you can speak over here. So I will tell, and I will take over here. Just tell me right now, what is the size I must keep as a testing data? Just tell me right now. Anyone?
30.
30. So in front of you, I can tell you 30. 30% size I am taking as a testing data, and random state I am taking as the 5 and integer value. You can pass any one, whatever you want to pass, you can pass. So it's optional, but you are not picking. So it's optional, but if you want to write, then you can just pass on the integer value. No issue. What is B? Okay, 1, 2, 3, 4, 5, whatever you want to take, you can take any random value. So no issue. After this, executing this code in front of you, so X training data and Y training data I will keep, and X testing data and Y testing data I will keep. Now I'm executing this code in front of you. Now we are executing. So it will take few couple of seconds to determine or to bifurcate your data into two parts. One is the testing data and training data. And 625 we can have the total data. So 625, 30% we will approx. We will keep the how many we will have it. Yes, approx we can say 30%. We will keep approx. I can say
187.
187. Yeah, something 180 something. Or 180, 190 something. Okay, approx 190 something. It will come automatically. So here you can say I have divided my data. So I'm printing the extent. So extent we have the 437. Okay, and we have 180. Okay, so approx 190 I got it. So approx we have the testing data 188 out of the 625. So you can see the proof over here: the training data, testing data, by testing data, and by training data. We have all the things over here. So now what we have done from our previous learning part, we have
Excuse me, sir.
yeah, yes, tell me right now.
Sir, I have a suggestion. Means right now we have taken training data 0.3,
Yes.
188.
Hmm.
But if you will look at a test set, it only contains 625 instance. If you are taking almost 1/4 of the instance, that is 200 in
Hmm.
training set, then might be the model will not able to find the pattern, sir. So
No,
if
no,
you,
no. Actually, what happened in the testing data should be lesser than that is I've already informed you many times. Training data should be greater than, but if you're picking the testing size, then testing size should be the smaller. The reason is clear because testing data is just used as a sample data out of our many entire data. So you must keep always testing data is smaller. But if you want to make it as bigger, then you can bigger. So it's the option size.
sir, I'm saying I think it should be we should take 0.2 because our total whole data set contains only 625, and if
Hmm.
we only give if we take only 200 instance to test site, then only there will be only 400 left instances. So might be the model will not able to learn the underlying pattern. So we should
No. Yes,
take
yes, yes.
0.2. It will be better, sir.
No, it's see, definitely I'm saying over here, whatever percent you want to take, you can take the model. See, if you're writing the 10%, you're writing the 5%, you are just taking the 2% of the testing data, your model will also be built and your model will give the result. But from your testing data size, from your training data size, your model will generate the accuracy. So definitely I will show you my proof over here. If you're choosing the minimum size of the testing data, then what is the accuracy you are getting? And if you're choosing the accuracy or testing data size smaller, then what is the accuracy you are getting? So no problem, I will tell you. Okay. First, let us assume we have the testing data. We are taking the testing data 30%, and we will do work based over here. And after according your words, I can amend. So if you want to update this one, then we can update. Just tell me right now. Should I update?
Yes, take
Okay.
0.2.
Okay. Two. So I'm updating this code. I'm just executing. Now we got the 500 rows, and we have the 125 as a testing data. So no problem. According to you, Niman, according to you, we can do. So it doesn't mean what is the percentage you're taking. Some students are just trying to using the 50% as a training data, 50% of testing data. So at the time, model will not be trained better way. So if you want to train your model in better way, then always keep your training data in good volume. So train model will be built in perfectly and accuracy. Definitely accuracy you can get in better way. So you are on the right point. So definitely I'm speaking over here, but as a user convenient point or user defined things, I can keep 65% as a testing data. So it is also possible. But I suggest to all the people while building the model, while training the model, you must always keep your model as a better way. So always keep the training data in to come is more volume than the testing data. So that was my point. So you're on the right track. Okay. Now it is good. So I have changed my information. Is it good? Should I go with this 20% testing data? So now we got
Yes,
the
sir.
120. So I'm going through the 20% testing data. So now I'm just let me explain this point. Next one. Now, after building the our after preparing the data set properly, after getting the training and testing data, now it's time to train the my model. So after training the now training the data we have. So now model will be trained, or we can say the model will be built on what parameter? Model will be require an important point that is known as the training data. So unlike the sklearn model scalar model selection, we have a linear regression class. So we have over here the Decentric classifier method by which we can use the tree classes and the tree classes from the sklearn package. I'm using the Decentric classifier, a method in which we have the various parameter by which we can do. So now we are building our model by just using the appropriate libraries in the Python programming, and that is more and more we can say the important properties, or we can say this is beauty of the Python programming, by which you can learn the many things in the scratch mode. So from the SQL libraries, I'm using the trees class in which we have a method that is a decision tree classifier. So this is the point you have to understand. So we are creating the object of the Decentric classifier, unlike the linear regression and polynomial regression we have created. And entropy, we are using the entropy means we will get the information gain. So entropy, what we have to pass? We have to pass the entropy we can pass. So in if I'm passing the Gini, so Gini, just let me write over here. So for a betterment, so this one, yeah. This is the point. So first I'm creating my object name, that is my DTC. So I'm giving its name, but if you want to update, then you can update, no issue. So my DTC I'm keeping as it is a variable name, and Decentric classifier in which I have to pass some parameter, that is a criteria. What is the criterion you want to pass? So I'm passing the entropy. So this is a entropy point you have to understand. And random state you can pass randomly. We can pass the first option, but if you want to pass, then you can pass. Next we have the maximum test 4 we are choosing, and next we have the minimum sample leaf, that is a 5. So if you're defining the maximum depth 4, so maximum depth we can have the 5. So if you're updating the maximum date, if you're updating anything, so definitely your tree structure would be changed automatically according to the maximum depth of the tree and minimum sample of the leaf at each and every node at the bottom side, leaf node side, we can say minimum we have the 5. This will be more clear while seeing the diagram. So before that, just let me show all the proof. So this is the point we have decided. But instead of the entropy, if you want to pass the Gini, so this Gini will decide the Gini impurity. So let me write correctly, Gini impurity. While getting the information again, you have to pass the parameter as a criteria entropy. So we will get the information gain. You have seen this example. But if I'm passing the Gini, so I will not get the information gain. I will get the Gini impurity, by which I will decide the splitting. So splitting at the decision tree will be done by the 2 level, but we have seen the numerical portion 1 level, that is only sufficient. But as a numerical, we have seen the entropy information gain. But practically, if you want to update something up, of course, it is also possible. So we have the other parameter Gini, and we can use this point. So we will get the Gini impurity rather than the information gain. And now after this point, now we have to fit the model. So it means now our model is building actually. Internally, our model is building towards the training data. So which parameter I need to pass? I need to pass the extend data and button data. So our model will be built by the fit method by choosing the training data. So I'm passing only those data. So this is the point you have to understand. So some points I'm speaking over here. So listen carefully. Criteria I'm giving here, Gini or entropy I can pass. So this function basically what we have to do. This function is measure the quality of the split which you want. You can use the Gini, or that is by which we are getting the Gini impurity, or you can pass the entropy, so by which we can get the information gain. Next we have the random. So random I'm choosing the as a 5 value. So if you want to update something, then you can pass. So this is defining the while designing the tree. So randomly our nodes are selected. But if you do not want to select, if you do not want to write, so it will select, it will depict the, or it will choose the appropriate nodes by the best approach method. So if you remember the algorithm of the artificial intelligence, when we have seen the best first search. So tree can be depicted, tree can be designed by the best first search method. So if you're not writing any randomness option or random method, then it will choose automatically best first method for BFS, best first search method, to depict your model for the searching purpose. And so the strategy that is used to choose the split at each node, and supported strategies are the best, I just told you. And to choose the best split method, or randomly we can choose a random split. And the maximum depth. So maximum depth, if I'm giving over this, so maximum depth of the tree will be have to pass over here. And if we are not passing anything, so nodes are expanded until all leaves are pure. I'm speaking once again. If I'm not passing the maximum depth parameter, because it is optional, but I'm passing, then it's okay. If I'm not passing, then the nodes are expanded until all leaves nodes are the pure, or until all leaves contain less than the minimum sample split sample in which I pass the 5. So if I'm not passing, suppose I'm not passing the minimum sample split, then how it will decide? So it assume that minimum sample whatever you're passing, it will assume that is a 2 automatically. So minimum you have to choose a 2. If you're not passing, then no issue. But if you're passing, then always keep the minimum sample split value, that is the 2. So if I'm passing, then it's okay. If I'm not passing, then it will decide automatically 2. And minimum sample leaf we have. So here in this example, what we have, if I'm not taken the minimum sample split, but here I have taken the minimum sample leaf. So the minimum sample leaf decide the minimum number of the sample required to be at the leaf node, and a split point at any depth will only be considered if it leaves at least some values which are defined by us. So if I'm not passing here, then what happened? One is required. So it will assume definitely there needs at least one leaf will be there. So based on the training sample, training data, what we have, and each n on the left and right branches, and this may have the effect of the smoothing of our model, and especially in the case of the regression. So while choosing the Decentric regression, this will be more effective. But in the Decentric classifier, it is not more effective. That is an important point. But as a parameter we have given, so we have to pass. Now, and other there are many other parameters. So I'm remembering some parameter I can speak over here. The minimum weight fraction we can pass, and maximum features we can pass. Okay, so there are many parameters. So there are some limited parameters given, so by which we are just trying to depict our model properly. And now, is it clear to all right now? The syntax is clear before building my model. Is it clear to all right now? Yes, tell me right now. Is it clear, or anyone who need to ask any question, any doubt?
Sir, minimum sample leaves means each leaf should have at least 5 instances, no?
Minimum sample leaves means you have to, this is optional parameter, but if you're passing, it means at each and every node. So it depends on your maximum depth. What is the depth you are deciding? So based on this parameter, minimum sample will be the 5. It could be 1, it could be 2, but minimum we can have. So maximum we can't decide. Minimum sample leaf, I'm speaking once again. Minimum sample leaves, we are talking about the minimum number of the sample required at the leaf node. It means total number of the leaf node what is we are depicting here. We can have the minimum 5. It doesn't mean what is the maximum depth you are taking. It can have the more than the 5 leaf node, but at least 5 leaf node will be depicted. No problem. I will show my proof, so it will be better for you. No problem. With the help of my practical, by the example or by the diagram, definitely it will able to understand properly. Definitely you will able to understand. So suppose I'm to design entry. I'm taking simple example. So while designing tree, what is the leaf I'm getting? I'm getting the 2 leaves. So 2 leaves are I'm getting. So what it will do if I'm passing the parameter, it will change the distant node of parent nodes, and it will depict it at the bottom side. So I have to keep minimum 5 leaf node. It will automatically decide. It will automatically decide. No problem. I will tell you. I will tell you with the help of my example. With the help of the example, I will take. Okay, no problem. But so far it is clear to all right now.
Yes, sir.
Okay, so let me execute this code first, and let me build the model first. After building the model, you got a message over here. So let us get the predicted values. What is the predicted values we can get based on the testing? So by predicting variable I'm taking, if you want to some amendment, then you can amend, no issue. I can amend some over here as previously we have done the for the prediction purpose, that is a predictive method. So I'm passing the testing parameter. I have, for the prediction purpose, what I have to pass? I have to pass only the predictive value. So I'm passing the predictive values over here and just see what is the actual value I have, and in the case of the testing data. So testing data, if you remember the total, we have the 125 while choosing the 20% of the sampling, 20% of the testing data. So now we will get the predicted values over here and we will get the testing data over here. Why I'm getting the predicted? So this predicted variable will calculate my accuracy of the my model. So what is the accuracy I have? So let me first show this proof. After executing this code, okay, first let me execute the previous one code. Now next one. So now you can see. So in the by test and the by prediction, I'm getting over here. So I'm getting the prediction RLL. So this is what is prediction? The prediction of the actual testing data. I have the sample. What test means? Testing data of the my class name. So I can write over here. This is the testing data of class name attribute. So I can write over here for betterment. Okay. And this is the predicted class name of the this is predicted class name, nothing else. And this is the testing data of our class name. So this is our, we can say this is the actual. This could be the actual. This is actual, and that is the testing. This we can say this is the actual data of the class name attribute, while this is the predicted class name. So here you can observe over here. Here we are getting the something properly. So 1, 2, 3, 4, 5. So first we are getting the RLB. So here I'm getting the RL. Till 4 we are getting the everything is okay. But actually we have the B at the 5th position. But here we are getting the predicted part, that is L. So it means there is some gaps we have. So how we can find our model accuracy? What we have? With the help of this parameter we can say. So with the help of the accuracy score method we can easily see. So let us evaluate the my model. So I'm not depicting the graph first. I'm just evaluating the my model is perfectly working or not. So what is the accuracy I have in the my model? So regression, we can get the regression part from the MSE. So MSE that is used to calculate that is used to evaluate the my model. So in the regression we have discussed. But in the classification, there are 3 different parameters. If you remember the working structure of the Decentric classifier model, if you remember the Decentric model, working of the Decentric model, where we have seen the accuracy, precision, and recall were the 3 important points by which you can evaluate the model. For your betterment, I'm just taking the first one only. So I'm giving the variable name, that is result. So from the SQL library, from the metrics part, from the SQL package and the metrics class, I'm using the accuracy score method, and with the help of the accuracy score method, I need to pass 2 parameters. One is the predictive parameter, other one is the testing parameter. So it will return the ranges from the 0 to 1 only. So what I will do, I will multiply the 100, then I will get the accuracy score over here. Okay, so I have already written over here. Now I'm executing this code in front of you, and let me show my proof what I'm getting. I'm getting the model accuracy, that is 72%. Is it visible to all right now?
Yes, sir.
And now if I'm changing, see, no problem. In front of you, I can do something over here. If I'm changing now I'm changing the parameter of the testing data size 30%. Now, so if I'm changing this one, so let me check. If I'm changing the testing size, then what is the accuracy I'm getting? So let me execute all this code once again. And so if now I'm getting the accuracy 77.65. Can anyone tell me why if I'm changing the less training, I'm changing the testing size, or it means I'm keeping the 30% testing data. So why I'm getting the accuracy score accuracy percentage better than the previous one? Can anyone tell me right now?
So because overfitting.
Yeah, super. That is the brilliant answer I'm getting because you are fitting your model by the maximum training data. So at the time your model was overfitted, and definitely you have see that is the beauty of the machine learning approaches. After changing the parameter, you have to identify if you're changing, if you're keeping the 30%, or if you're keeping the 10%, you are keeping the 15%, 20 or 25%. So at what is the percentage you are having the better accuracy. So previously what I have taken, previously I have taken the many size of huge size of the training data, that is a 400 something or 500 something, 500 exact 500. So at that time my model was overfitted, but in this case my model was not underfitted or overfitted, it we can say the average fitted. Suppose I am keeping the minimum size of the training data, so there is no guarantee that time my model was underfitted. So definitely this is the issues. Yeah, definitely this is the issues of the machine learning model, and we will see these issues in detailed manner. But now this concept should be clear to all right now. Is it clear to all right now?
Yes, sir.
So I suggest to all those students always try to keep the testing data size 30 to 35% only. That is sufficient. Okay, so your model will be close to the average fitting. Okay, now let us move to the next part. Now it's time to display the Decentric graph, because without the graph, how we can say what we are getting? That is the only reason only. So I have just given some information properly over here. So from the class name, what we have the class name total 625. So out of the 625, we have the many class which contain the B, many class which contain the R, which class the R. So we have to get the uniqueness in the our information. So we have only three. So with the help of the unique function from the our list method, keep in mind, from the list method, this is the list method in which I am using the unique function. So from the our this variable, that is a my df variable, which is the array type of variable, I'm passing the array type of the variable which contain the total 625 elements that belong to the R, L and B. So I need to choose only the uniqueness, I need to find the uniqueness. So I'm making the variable, and that is a target variable. So by applying the unique function or unique method to make the list of the element by the list method, to make the list of the element by list method, so we can do this activity. So target variable will keep the three different type of the element. One is a B, R, B, Rn. So remove the duplication. Now features name, other features name I am taking over here, that is my independent features. What are the independent features? Left, right, and left, right, its distance and width. So all the columns which are belong to the columns name will come over here. So from the X variable, so it will keep the list of all the columns of the features except to the class name from the X variable, as we have seen the few minutes before. So let us print all these things, what it will contain. So this is the point which is required to use over here. So now we are getting the column names of the our target variables column name, and it will display the column name of the feature name. Now, is it clear to all right now? We are printing and we are getting the thing. Is it clear to all right now?
Yes, sir.
It's very simple method we have seen while discussing the list method. Those students who were more involved in the Python learning, so they know these are the various methods by which we can display the thing properly using the list part. Now it's time to display the graph. We don't have any use method. We have a simple method by which we can display. So it's time to use the Matplotlib library we have already taken previously. So I'm just read multiple time using, it's optional, but if you want to read, then you can use it. So with help of the tree, from the sklearn package and the tree libraries, what we can do from the sklearn package, from the tree libraries, you have to use the thing properly. So in the tree libraries which contain the plot tree graph. Why I'm taking this one? For plot for using tree plot graph. That is the only reason we are using the tree plot graph. We have to plot. So from the matplotlib library, with the help of the object of the matplotlib library, p by plot class, I'm using this point. So I'm passing the figure size, that is a 12 by 12. You can pass, you can change it, no issue. And tree plot I'm passing over here. So what is the parameter I have to pass? I'm speaking over here. Listen carefully. I need to pass the parameter of the my DTC. My DTC is the this is the what? This is the object of the tree classifier. A few minutes ago I have prepared. That is my DTC, and I just need to its font size. So for 8 I am taking to display the my node name and the details perfectly. And class name. So that is a target I have to pass over here. So I'm using the class name as a target. Okay. Target, I'm just what is my variable name? That is trag. So TAR, yes, TR. So class name, so I'm using the trg, and field is true or no, so it is optional. So class name and other are the optional, but if you want to write, then you can. But so that's why I'm just writing over here all these parameters, so my information will be displayed in colorful manner only. But these are one parameter of main important, that is you need to pass at least the object of the Decentric classifier, and our graph will be shown over here. So first let me show the proof. It will take little some time to plot depict all the things. Now the graph is visible to all. Yes, tell me right now. The graph is visible. This graph. This is about Decentric. Is it visible to all right now?
Yes, sir, decision to
Yes, sir.
And now, what is the maximum depth? What is the maximum depth? We have taken 4. So you can see this is a root node. Now on the left and right, you can say 1, 2, 3, 4 depths we have. So we have the 4 depth. Okay. And what is this x1, x2, and x0? X0 is defined, that is the first column name, x1 is the second column name, and third is the column name. So x1 is our left distance. So left distance, it was chosen as the best feature for splitting the our information. So when we have the left distance, which is less than or equal to 2.5, so our information will be bifurcated. And what is the entropy we are getting? 1.334, and samples, total samples, that is the 437. It has to take first for dividing part. Okay, why 437? Because our total training data we have taken. CC here. Everything you have to do. Yeah, 437. 437 was the training data, and our model was built by the training data only. So that's why the training the descent tree will be depicted by our training data only. Okay, that's why we have taken this one. 437, and now spreading. Now spreading will be going to sample 177 will come on the left side, and 260 will come on the right side. And now x2 means we're talking about the right weight, and x0 left weight. Now clear? This tree is clear right now? Just tell me right now, is it clear? Say yes or no.
So what is value that is 1741,119 in each node?
Yeah, this is the value 1741,119, which decide that is the what is the value on which the our information may be split. So at the 17, see this is the 17 number row at which our information was split. And 17 one was 41 was other row at which we can split, and 119 is our row. So all these rows which are representing by the class L, that is a left class, we can say at which level this will be divided, our information will be divided. So now see 17 I'm choosing 17, so 17 I'm choosing. So here we have the 5, 24, 10. So at C you can divide your rows or you divide your data into the two different parts, left and right. So what is the 17? What is the 14? What is 119? So at what row at you are choosing for dividing your part right now? That is only sample. That is only the point. So this 41 saying the root value. This 41 is saying the root value and 17 saying the 17 is saying your left value, and 119 is the our row number at which we have used the right way. So where this node is chosen as a right part. So 41 is the value of the our descent node or intermediate node, we can say over here. And total sample here we have the 177, so we have to bifurcate all the data. And this at what is node which is identified by the x2, x is the left, so L. So when we have the L value that is less than 1.5, so for those who are lesser than, so it will come on the right side and left side, and those who are greater than, so it will come on the right side. It will automatically decided by the Decentric classifier. User involvement is not required. Let me change something so the picture will be more clear. As I told you, maximum days I am taking only 2. See, I am taking 2 only. Minimum least sample lead I am keeping only the 5. It doesn't make. Now I am building my model once again. I am just using. So see here how many depths we have. Just let me you can see how many depths we have. We have 2 depths only. 2 depths we have. Okay. So now we have the 2 depths. Now 41 will become now features was chosen as a x1. Okay. And for total samples we have the 37. Now our samples we have the 177 over here and 260 over here. So we are not changing anything over here. And 17 over the left side, this is nodes value we can say, and 41 is our root node, and that is the parent node we can say, and 119 is the right node. So now we have good this point. So minimum sample we have the here due to the maximum depth we are getting the only the what is the maximum depth we can have 2. So due to this issues, every node descent node can contain the right one left node and one right node. So here I am getting only the 4 leaf node only. But if I'm changing update something, if I'm changing, say where I am the update, yes. See yeah. Suppose I'm updating maximum depth 3. And now let me execute this code. Yes. Now, so now my descent tree is more expanded over here. So based on your maximum depth, your descent tree will be expanded automatically. That is the reason. So it will have the many things. If I'm not passing any parameter, I'm leaving the. So what happened? It will decide. It will split your descent tree node based on the pure data only. So wherever we have the impurity, then such node will not be considered because that node contains the impurity part. So that's why we have the next statement which describes the calculating the impurity. So this is the point. So this is a very simple code we have. This decides the impurity in our data. This is only the each and every node. So we have these list of the node 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So here we are getting the total 15 impurity. So what is impurity we are having at each and every level? So you can check over here. So this is impurity, and this is the entropy we are getting. So this is the impurity value we are getting. This is the entropy value we are getting. So this is only nothing. This is only our data we are getting. So this is only the formula by this is our method variable by which we can calculate. But this is an option. But I am telling you right now how to calculate the impurity in our descent tree. And now let me just show my proof, and definitely you will be surprised to see the many things. Even changing the maximum depth, it's 10. See, just see the output. So again, it will take many times because the splitting will take many times to calculate all the points properly. So now our descent tree will be more complex. Now see. See, this is the descent tree we are getting. And now what is impurity? So number of the nodes we have, so the impurity will be calculated automatically. Some nodes are having the impurity 0, it means there is no expandation is possible. So this is some nodes are not expanded and from the left and right, so it means they are getting the impurity 0. This is only one. Now it is clear to all right now. Is it clear? And now when you change the testing data size, so your training data will on the.
Sir, maybe Maybe the accuracy have increased because we have increased the depth of the subtree, so classification will be done on various
Yes, of course, of course. So see,
accuracy might have.
this descent tree here, I'm just using the depicting purpose only. So descent tree, it just used to classify the data. So here, what you are deciding, you are classifying the data in two parts. So descent tree implicitly work with the binary tree manner form. So that is only the beauty. So descent tree basically a machine learning model which is work implicitly work on the binary tree. So it can have only the zero children or two children. Okay, so zero children it means no children, but at least contain the two. So if we're having the one, so there will be no sense we can have a binary. So that is the beauty of the descent tree. So it seems as it is very easy internally, but it is not easy internally. If I am doing this problem by the my calculated part, if I can do, but it will take many times. But help of the my this model I can do. So this is the only the sample that I am taking all the 625. But when we have the 10,000 or maybe the 50,000 data, then now think and feel what would be the complex structure I have. So that is the beauty of the machine learning model, by which we can sort out the many problems in concise way. That is the reason. And now we can store all these data which is depicted by our decision tree graphical way into the form of the textual way. Yes, of course, is also possible. And here we have a simple command, nothing as export data. We have to use the export data class from the tree libraries. And in the result variable, I'm taking what I have used just what see what I'm using right now. I need to pass the my DTC variable name of the our object name of the our Decentric classifier and export data method we have to pass, and features name I'm taking the fee name only, nothing especially, because I have to export my data based on my features. Now I'm using the syntax. Now you can see this is the our point. So where I'm choosing the left distance. So with this tree kind of the manner of textual data, you can easily say first, I'm taking the left distance is less than 2.5. Yes, see, when I'm x1 is my value, this array index values of the my our features name array variable. So, second one, that is a left distance. So here I'm just able to see. So from this perspective, I can able to see what is my flow of my tree where I have divided. So this is all the things. So this is the point. So as soon as you can see you are just keeping the minimum maximum depth, then you are having the minimum part of the minimum size of the descent tree, because the spreading is not bifurcated towards the maximum depth, but we are keeping the maximum depth is as much as possible. So you are having the descent tree classified in more and more depths. That is only the beauty. So nothing especially. This is only the display purpose and graphical purpose only. Is it clear to all right now? This is the commands by which we can do. This is the Decentric classifier, and this is
So what is the current accuracy out of order?
current accuracy. I have already calculated. Now, what is current accuracy? This is the 78. 78. Current accuracy we have 78. See, when you are having the huge volume data, when you're working on a real project, so your accuracy may change from the 60 to 70, 80, because whatever the actual data you are having. This is only sample data on which we have worked. Here we have the very small amount of data, 625, nothing else. But when we work on the actual data, when we're dealing with the thousand data, so at the time we have to keep in mind the accuracy should be perfect or not perfect, at least should be close to the perfect. So our model will be better than the other model. So here learning will be done properly. Okay. Is it clear to all right now? Or any doubts so far?